Hello everyone, this is CJ Peaceful again. Just want to show you what I've been working on the past day or so. I saw a video, I guess it was a couple of days ago now, that a gentleman by the name of Zero Fossil Fuel had created this HHO cell using stainless steel plates. I believe it's about between 23 and 26 plates or something like that. I can't remember the exact number now, but he did have neutral plates. I believe there was about 5 plates between each electrode, maybe 4. But what I noticed was quite interesting was the spacing between the plates. I believe he said in his video that his stainless steel that he was using measured about 0.04849 inches thick. That's pretty thick stainless. And I believe he said the gap between each plate was about the same thickness, or maybe a little bit smaller by 0.001 inches. I started thinking about this after seeing several of his videos. Maybe the gap, the spacing between the plates, there has to be some reason why a cell such as his, the VSPB I believe is what he calls it, produces so much gas that and the spacing between the plates is so small, yet he has no heat problems. Of course, that's probably due to his neutral plates. But the production, the amount of gas he's able to produce in a minute, and the efficiency of the cell is quite good. Now, I've heard a lot of people say that if you go less than, say, 3 millimeters, or approximately 1/8 of an inch thick, or less, in your spacing between your plates, you have a tendency to have problems with fluctuations in your current. I never quite understood what they were saying, but I thought, well, maybe they're talking about, as the water is cycling through the cell, you could get some sporadic gaps, if you will, air bubbles trapped in between the plates at various times through the electrolysis, which would cause your fluctuation in your amperage. Therefore, an accurate assessment of how well your cell is doing would be very difficult to pinpoint. But I started thinking about this, and what I have done is I've taken some scrap pieces of stainless. These are from a cell that I'm currently working on. This is not from the VS9. This is from a cell that the design was actually from John Ahrens, his idea. It's a little bit bigger cell than his, but still 11 plates nonetheless. And this stainless measures, I think it's about 0.30, or I think it's 20 gauge is what it is, the thickness of this stainless plate. What I did was, quickly, I wanted to see if I could get any production from a plate gap of this thickness. So basically what I've done here is sandwiched one of the plates between the 2 pieces of stainless, put a little dab of epoxy here and here, let it dry, pulled this plate out, and I took 2 pieces of tape and stuck it to the sides of the plate, and that's what I got there. Now, I wanted to see if I could reproduce this fluctuation that others have been talking about when you run into this extremely tight spacing. I think you'll find this interesting. Okay, let's see. Sorry for that pause in the video. I lost power there for a minute. Okay, where were we? Oh yes, we're about to test this very small cell. Again, the plate spacing is approximately 0.03634. I'm not sure exactly what 20 gauge is. I believe that's pretty close. Just sort of as a visual reference here, this is a plastic card, about the thickness of your average credit card. And that is actually the thickness, excuse my phone there, of the plate that I'm using. Just sort of give you an idea, a reference of how thin that gap is between the two plates. I know in this acrylic tube there's a bit of a visual distortion here on the edge. As you can see, it looks like a fairly sizable gap, but trust me, it's not. I can take this out, show you quickly before I run out of memory on my card. See, it's quite thin, quite thin. I really wish I could focus in on this, but again, I'm using this a still camera in video mode, so this is the best I've got to work with. But anyway, let's put this back in the water. When I say water, again, this is filtered water. I did not put any electrolyte in it this time. I just wanted to see what kind of reaction I would get. Here is my amp gauge, and of course you've seen the jumper cables. I plugged into a 12-volt battery there that's behind my table. And let's see what happens. Let me zoom in tight here just a little bit and see what we can get. And here we go. All right, there we go. Wow, that's pretty good. That's pretty good. I hope you all can see this on the video. We are getting some action going here, some gas production. Let's see what our amps are saying. Oh boy, as I thought. We are getting probably, well, maybe a quarter of an amp, maybe 250 milliamps. I guess that's okay. 12 volts. Fairly decent production, I guess. Let's go ahead and let's add some lye to the solution and see what happens. Maybe I can recreate this thermal anomaly that a lot of people have been saying that occurs when your plate spacing is much too great, or excuse me, too close, and you get a fluctuation in your amperage, in your current, causing all kinds of problems. Let's go ahead and disconnect the cell. We let that water clear up for just a second or two while I measure out some lye. Again, filtered water, a little bit of lye, at least that's what my bottle says. I'm measuring about a half a tablespoon. Go ahead and dump that in the water. I don't feel like we need to stir this up. I think the thermal currents will take care of that. Alright, according to my timer, I have about 30 seconds or so to turn this back on and see what happens. So here we go. Oh wow, look at that. Wow, look at the size of those bubbles. – That's really nice. How many amps do we have here? Oh, look at that. Now, there's some fluctuation there. Of course, that could be just the stirring of the solution because of the thermal currents. We got approximately 7.5 amps. Nice.